Hello students, Assalamu alaikum. Welcome back to the session of chemistry. Today in this video lecture we will try to understand mechanism of free radical substitution reactions. In the previous video we learned about the methods of preparation of alkyl halides. So this was the reaction which we understood there. CH4 alkane combines with chlorine in presence of sunlight. It gives HCl and CH3Cl. That's methyl chloride as common name and chloromethane as IUPAC name. Now let us see the mechanism of this reaction. This mechanism is comprised of three steps, three processes. We can say number one is initiation step. In initiation step we come to know how this reaction starts, and next step is propagation step. In the propagation steps we understand how this reaction proceeds, and in the last step, that is termination step, in that very step we come to know about how the reaction ends. So let us first of all see this initiation step, or we can say initiation process. First of all, this all happens, as I already told you, that this all happens, these are photochemical reactions, all happens in presence of sunlight. Here you can see the chlorine unit, sunlight falls on this unit, and you can see two chlorine atoms which undergo homolytic cleavage. Homolytic cleavage means breaking of bonds. Each chlorine atom gets its electron, each chlorine gets its electron which from the shared pair of electrons and become free radicals. Here you can see formation of two radicals from this chlorine unit in presence of sunlight. So two chlorine free radicals are produced in this initiation step. So in initiation step, sunlight falls on chlorine unit and forms two free radicals. Now the reaction starts. Now what happens in the next process, propagation step? This free radical combines with a fresh unit of methane, CH4. You can write it like this: CH3 and H, CH bond, because one of CH bonds undergo homolytic cleavage and forms H free radical and CH3 free radical that combines with the free radical of chlorine already formed. And here just see what happens. Here forms two types of free radicals, H free radical and CH3 free radical. This H radical is unstable and CH3 is very much stable radical. So this chlorine radical combines with this unstable H free radical and gives HCl and free radical CH3. Dear students, you see what happens next. This free radical, CH3 free radical here, combines with a fresh unit of chlorine. This chlorine unit undergoes homolytic cleavage, that's formation of two fresh free radicals. One of the free radical among these two combines with CH3 free radical and forms CH3Cl. That is chloromethane, IUPAC name chloromethane, or you can say methyl chloride, and Cl free radical. So one Cl radical combines with CH3 free radical, gives CH3Cl, and along with Cl radical, chlorine radical. Now see what happens next. This free radical can attack the CH3Cl here. Now see, dear students, what happens next. This Cl radical, there are two possibilities. Either the Cl radical will combine this H atom in CH3Cl or a fresh unit of methane. But let us proceed with this. CH3Cl. I have written the structure here, CH bond, because one of the CH bonds undergo homolytic cleavage and forms two radicals, H radical and CH2Cl radical. So this Cl radical combines with this unstable H radical, gives HCl, and leads to the formation of CH2Cl free radical. Dear students, very easy to understand. Now this CH2Cl free radical combines with a fresh unit of chlorine. There are two free radicals again produced by undergoing this homolytic cleavage, formation of two free radicals, chlorine radicals. One of the chlorine radical combines with CH2Cl radical and gives CH2Cl2, that is dichloromethane plus one chlorine radical, one chlorine free radical. This chlorine free radical combines with, there are two possibilities. Either this chlorine free radical attacks this hydrogen atom from CH2Cl2, or it can attack a fresh unit of methane. But let us proceed with this chlorine free radical attacking this CH2Cl2 here with this hydrogen atom. CH2Cl2 CH, ये देखिए, here you can see CH bond which undergoes homolytic cleavage. Here is chlorine free radical that combines with this hydrogen free radical, which is unstable and forms HCl and leads to the formation of CHCl2 free radical. Here you can see CHCl2 free radical. Dear students, let us see what happens. This is CHCl2 free radical combines with a fresh unit of chlorine. There are two free radicals produced. One of the free radical combines with this CHCl2 radical and forms CHCl3, that is trichloromethane, and gives a fresh Cl free radical. This free radical, there are two possibilities. Either this free radical attacks a fresh unit of methane, or it can simply attack this hydrogen atom in CHCl3. So let us proceed with this. So CCl and H, this is CH bond and 3 chlorine atoms. This CH bond undergoes homolytic cleavage, and this chlorine atom, this chlorine free radical combines with unstable hydrogen free radical, gives HCl and gives CCl3 free radical. This free radical, here you can see this free radical CCl3 free radical combines with a fresh unit of chlorine which undergoes homolytic cleavage. Two radicals are formed. One of the free radical combines with CCl3 free radical, gives CCl4, that is tetrachloromethane, IUPAC name, or we can say carbon tetrachloride, and one Cl radical. Dear students, here you can see this is the final product CCl4. This is not our desired product, because as I already told you that in this halogenation process we cannot get the desired product, because we are supposed to get haloalkane, which the reaction does not stop there, and it proceeds further and forms the product which is not our concern. Now all the reactants almost get converted into products, and some species are left in the reaction mixture, that is CH3 free radical and Cl free radical, which further get converted in the termination process. Here is the termination process. There are two types of species left, that is CH3 free radical and Cl free radical. Let us see what happens. If Cl radical combines with other Cl radical, it forms Cl2. Or CH3 free radical combines with Cl radical, it gives CH3Cl, that's chloromethane. Alkyl halide we can say also. Third possibility is that CH3 combines with another CH3 free radical, it gives ethane. Dear students, I would like to mention here that this C2H6 yani ethane, it is produced in very small traces. You can be asked this question in the examination. Ethane is produced in very small traces. Dear student, this was all about mechanism of this reaction. Now let's discuss the next point, that's rate of reaction with respect to halogens. Dear students, here you can see we have taken an alkane which reacts with fluorine, that's fluorination, this fluorination process. It gives RF, that means alkyl fluoride. As far as the speed of this reaction is concerned, that is fluorination. The reaction is very fast and is uncontrollable. This very fast reaction, this is vigorous reaction, this is uncontrollable reaction, and it's very fast. Next, alkane with chlorine. Alkane with Cl2, that's chlorination. In presence of sunlight, all these reactions take place in presence of sunlight. Here you can say alkyl chloride. This reaction is also very fast but is controllable. First one was uncontrollable with fluorine, and second one is very fast but is controllable. As far as third reaction is concerned, that's alkane plus Br2 bromination. This reaction is comparatively slower than first and second one. Apart from this, let's move towards fourth reaction, that's alkane plus bromine in presence of sunlight. This reaction is very slow and is reversible. Here you can see this reaction. Alkane plus iodine in presence of sunlight gives alkyl iodide, or you can say alkyl iodide you can see this is the sign of reversibility. This is reversible reaction. So to make this reaction irreversible, dear students, as far as this reaction is concerned, this with iodine, you can see, to make this reaction irreversible, hydrogen iodide is treated with iodic acid. That is, hydrogen iodide with iodic acid gives iodine and water. First of all, let us see, we are supposed to discuss the rate of reaction with respect to halogens. So with fluorine, the reaction of alkane with fluorine, it is the fastest reaction and is uncontrollable. Second one is very fast but is under control. Third one is slower than first and second. And with iodine, it is very slow and is reversible. Dear students, next point in this lecture is that the rate of reaction with respect to alkanes. The rate of reaction with respect to alkanes. There are three types of alkanes. You can say 3 degree alkane, 2 degree alkane, 1 degree alkane, 0 degree alkane. Here you can say 3 degree alkane, 1 carbon attached to 3 methyl groups. This is 3 degree alkane. 1 carbon attached to 2 hydrogen atom and 2 methyl groups. This is 2 degree alkane. 1 carbon here attached with 1 methyl group and 3 hydrogen atom. This is 1 degree alkane, and here 1 carbon with 4 hydrogen atom. This is 0 degree alkane. So here is the order, decreasing order of stability of types of alkane. This is the most stable among these four. This is most stable. Dear students, here you can see the order of rate of reaction with respect to types of alkane. That's 3 degree alkane, 2 degree alkane, 1 degree alkane, and 0 degree alkane. Let us see the order. 3 degree alkane plus halogen. The speed of the reaction with 3 degree alkane and halogen, it is the fastest among these four. Next is 2 degree alkane plus halogen. Third one is 1 degree alkane plus halogen. And last one is 0 degree alkane plus halogen. Among these four cases, 3 degree alkane plus halogen reaction is the fastest among the four. Next is 2 degree alkane plus halogen, 1 degree alkane plus halogen, and so on. So dear students, this is the last point in this video lecture, Swart's reaction for preparation of alkyl halides. Swart's reaction for preparation of alkyl fluoride, because in the previous method we were unable to produce alkyl fluoride because that reaction is very fast and is uncontrollable. So here is the method, good method, very good method, Swart's reaction for preparation of alkyl halide. What happens in this method? We take chloromethane or bromomethane. We take chloromethane or bromomethane. It is treated with any metal fluoride. You can have silver fluoride. So chloromethane combines with silver fluoride. You can see this is metal fluoride. What are the products? You can see the fluoromethane or methyl fluoride, which is our desired product and gives silver chloride. Here you can see also this is bromomethane combines with silver fluoride, gives fluoromethane, our desired product, and silver bromide precipitate. Also you can have one more example. You can have this example, CH3Cl chloromethane, mercurous fluoride, metal fluoride, mercurous fluoride, and gives the product fluoromethane and mercurous chloride. So that was all in this video lecture. Thank you very much.